All right, everybody, I wanted to give you kind of a hint for setting up this homework problem. I'm not going to solve everything, but I do want to give you the free body diagram to get you started. So you'll have a normal, you'll have the weight, you'll have friction, and you'll have air resistance. And when we're actually setting up our equations, you'll need a little bit of we'll call this mg sine theta, which is the weight broken down. And here we'll have an mg cos theta. So just to be clear, when we write down the differential equation in part B, that's going to be mg sine theta minus mu mg cos theta minus the air resistance force, which is BV. And that's what equals MA, which we're going to convert to dV dt. Now, when we actually achieve terminal speed, that means that the acceleration is 0, so we'll end up getting mg sine theta minus mu mg cos theta from the friction equals BV. And so the terminal speed is actually given by this expression here. And then part D, I'm going to let you solve it on your own, but when you're done, your answer should actually look like this. mg sine theta minus mu k mg cos theta over b times 1 minus e to the negative bt over m. That's what your answer should look like. And this is what you'll need to prove on your homework. All right. Next question. And then if you want to graph the acceleration as a function of time, you'll get it this. But keep in mind, the acceleration is going to end up being g sine theta minus mu k g cos theta. That should be your initial acceleration. The other way to do that is just to prove it with the derivative. So I'll say prove this. Okay. Now, for number 2, let's keep in mind here, this part should be easy. This, you need to use conservation of momentum. And then to get the period, remember, t equals 2 pi square root of m over k. And to get k, you will actually use the fact that mg equals k times d. And then for D, for part D, use conservation of energy, where you have kinetic energy getting converted into elastic energy. And so for E, I also want you to look at it in terms of the period t equals 2 pi m over k and ask yourself, what is m? Now, for our oscillation problems, let's be clear. So here, if you remember, our differential equation is d squared x dt squared plus k over mx equals 0. That's the general equation. So I expect you to adapt that to problem number 9 and keep in mind that t is square root of 2 pi m over k. Now, just so you know, our position as a function of time is going to look like this. Our velocity is going to be omega a cosine of omega t, and our acceleration is going to be negative omega squared a sine of omega t. Here's some things you might not have considered from the trig. So our maximum displacement is going to be A. Our maximum speed is going to be omega A. And our maximum acceleration is going to be omega squared A. Those are some hints that can help you with some of these problems here. And so I hope you'll apply that to this homework. So here's your hints for the homework, and I hope these help.